Physics Challenge 15, Energy of Angular Motion. Okay, we have a free rotating rod. Weight is m and length is l. We attach additional weight m, lowercase m, and give a push with initial velocity v. Then it's move up to horizontal position and it's come back, right? So what was the initial velocity we gave in order to get up to the horizontal position? That's a question. First of all, this rod moment of inertia is 1/3 ml square, and you know torque is I, angular acceleration, so FL equals m L LAN, and this is A and L, so F equals fictitious mass, F equal ma. So we have inertia of 1/3 m. That's the inertia of the rod, and m, the inertia is m. Okay, so energy, kinetic energy is 1/2, and this mass plus m, and L omega square. So this is like this is kinetic energy, right? Okay, this kinetic energy is equals to potential energy, which is m go up to from here to here, so it's L, right? So L mg plus, how about this potential energy? Say the center of gravity is in the middle, so L/2 mg. Okay, so now we know we can get omega out of this equation, right? So the L omega square equals plus mg, it's m gl plus L/2 mg. So L omega equals square root of 2 mg L plus L mg over 1/3 m plus mg. Now we know V is L omega, so answer is, if we times 3 together, 6 m plus 3 capital M mg, not mg, g over m plus 3 mg. Okay, so that's the answer. Let's check the dimension. M, this is not correct. Where this g came from? Oh, we don't need this g. So it's a mass divided by mass, the g, this acceleration square root is going to be dimension is incorrect, we forgot something, L. Okay, L here. Okay, so let me clean up. mg is not here and L is here. Okay, so the mass cancel out the dimension, you multiply L and square root is going to be speed, this meter per second. It's a good practice to check the dimensions after calculation so you can find some errors during calculation. Okay, I hope you enjoyed these videos. You can check other videos, and if you like, subscribe.